We are going to learn how to add today, or to create a machine that adds our binary numbers for us. Before we can do that, we sort of have to understand how addition works. If you remember back in elementary school, when your teachers first started teaching you how to add, they would have you line the numbers up, and you would have 3 plus 5, which would give you 8. Or you might go wild and crazy and have 7 plus 4, which would actually give you 1, carry 1. And then you do 1 plus 0, which would give you 1. Once you sort of mastered all of these, they would up the ante, and you would get something like 35 plus 42. This would be 5 plus 2 is 7, and then you carry out a 0, which goes up here at the top, and you have 0 plus 3 plus 4, which would give you 7. Or another one to look at would be, let's do 356 plus 798. So in this case, I'd have 6 plus 8, which is 4, carry out 1, and that goes up here into the carry in, and then we have 1 plus 5 plus 9, which gives me 15, which I drop down, and actually it's 5, carry out 1, and then 1 plus 3 plus 7 is 1, carry 1, and then 1 plus 0 is 1. So that's how you add. If you notice on this, you basically have to be able to either add 2 numbers or 3 numbers. And as long as you're able to do 2 or 3 numbers, it doesn't really matter how big it is, you just have this chain of carrying out into our carry in on them. Let me switch that over to pin mode so you go from here to there. So I could take 2 numbers and add them together, and this is what we refer to as a half adder. Or I could be doing the 3 numbers together, which we refer to as a full adder. On that. So those are sort of the 2 things we have. Now let's transfer this over to binary numbers. So on this right here, I've basically given all possible combinations for a half adder. We are going to call this top number here my A string, and we're going to call this bottom number here my B string. Now that string is kind of just a simple fancy way of how to define a string. It's not what you use to tie your shoes up. It's just a chain of numbers that are connected together. In this case, our string consists of just one number. So there's our A, so we're basically doing A plus B. So in this case, our possible combinations is we have 0 plus 0, which gives us we have 2 things. We have the sum, which is what those numbers are added together, but we also have what we refer to as the carry out. So whenever you add, you have 2 outputs. You have your sum, which in this case 0 plus 0 is 0, and then you carry out a 0. In this case 0 plus 1, the sum is 1, and you have a carry out of 0. 1 plus 0 is a 1 with a carry out of 0. And 1 plus 1 is actually 0 with a carry out of 1. So those are all the possible combinations we can have when we add an A and a B together. Now, if you notice this and take a look at it, take this and rotate it 90 degrees and read down this way, you'll notice that this actually looks a whole heck of a lot like our truth table. So up here I have the half adder for a truth table for a half adder. And then if we just convert our information into it, we have here our inputs. We have our A string. This pen is not working very well. And we have our B string. So 0 plus 0 is 0 with a carry out of 0. And 0 plus 1 is a 1 with a carry out of 0, and 1 plus 0 is a 1 with a carry out of 0. And 1 plus 1 is 0 with a carry out of 1. And then hopefully you guys remember these are our inputs right here. And these are our outputs right here. And if you, once you have a truth table, you can simply do a K-map to get a Boolean expression. And then once you have your Boolean expression, you can build a working circuit, which we'll show you how to do in the next video. So that's great for a half adder. Only problem with a half adder is it only lets you add 2 numbers. And when you're talking about binary, that basically means you can add up to 2. And that's not a whole lot of use. You can do that in your head quicker than you could do what we did here. So let's go on and take a look at how to do a full adder and where that truth table comes from. So with a full adder, you basically are adding 3 numbers together. This first number right here comes from your carry out, and so we're going to call this one your carry in. Then the second number is your A string, and the third number is your B string. So this would be 0 plus 0 plus 0, which would be 0, carry 0. 0 plus 1 would be 1, carry 0. All 3 of these are the same. And then 1 plus 1 is 0, carry 1. So all 3 of these are the same. And then 1 plus 1 plus 1, 1 plus 1 is 0, plus 1 is 1, and we had to carry out a 1. So those are all of our possible combinations. So moving over here to our truth table, we discover that we can fill this in here. This is my carry in, my A, and my B. So in this case, my sum is 0, 1, 1, 0, and carryouts are 0, 0, 0, 1. And then right here, it's 1, 0, 0, 1, and my carryout is 0, 1, 1, 1. Once again, there are my outputs, and here are my inputs. Oops, I flipped what I said there. These are the orange is my outputs. Blah. Orange are my inputs, yellow are my output. Once you got a truth table, you can then do a K-map Boolean expression and build a circuit. And that's great. We can now add up to 3. So where this starts getting fancy is if we're going to add a binary number. Let's say we want to take 7 plus 8. Actually, let's get a little more exotic than that. Let's do 12 plus 5, which we know is 17. Well, the computer doesn't see decimal numbers, it just sees binary numbers. So I'm going to write the number 12 in binary, which is 12 in binary is going to be my A string number, and that would be 1, 1, 0, 0. So this is my A string. 5 in binary is 0, 1, 0, 1. Now, technically, the reason I put the 0 right here is just as a placeholder so that it's a 4-bit number. It doesn't actually change the value because it's in front of it, but that's why it's there. And that gives me my B string. Now I'm going to add these. And when I add, I'm going to end up having a carry out, because you remember everything is a sum. So in other words, I am going to add this column, I'm going to add this column, I'm going to add this column, and I'm going to add this column. When I add everything, every time you add, you create a carry out. Your carry out becomes your carry in for the next number. So how this works is I have 0 plus 1, which has a sum of, I'm running out of colors here, we'll go over to black. It was a 0 plus 1, which gives me a sum of 1, carry out a 0. 0 plus 0 plus 0 gives me a 0, carry out a 0. 0 plus 1 gives me a 0 as well, but with a carry of 1. 1 plus 1 plus 0 gives me a 0 as well, with a carry out of 1. And I'm just going to drop this guy right down here, which is the 16's place. And so I have a 16 and a 1, which gives me the number of 17. So I just added in binary. If you notice here and look at the yellow circles, this is basically a half adder, and all the rest of these are a full adder. So when I make this, you could build it discretely with the gates using your K-maps and Boolean expressions, but as you can imagine, this gets used quite a bit, so they pre-packaged it into circuits that are titled half adders and full adders. And what you're going to do is you are going to go get the little box in Multisim that is titled half adder, and we have one of those, and then it's a 4-bit. So for each bit that you want to add, you have to put in an adder. So if it was a 5-bit adder, you would be using 5 of these, but we're doing a 4-bit, so here's a half adder, and then the rest of these are full adders. And on the adders, you have a, let's see, what color choices did we use? We used blue, orange, and black. You have a string, and you have a B string. And this is where you put in your numbers. And you enter them in as zeros and ones. And then for everything we have an output, we have our sum, but we also have our carry out, and my carry out is going to be a carry in to the next one. And then this little guy's carry out, we just go ahead and drop on down. And if you watch the videos and they talked about how you had the dropped place, that's what ends up happening there. So there we go. And then we can put probes down here and switches it to input our numbers and probes to show our numbers. And I can't believe I titled that B because I meant to title that your A string. So if you were confused, there's your A string, there's your B string, there's your sum, and then your carry out becomes your carry in for the next adder. And your answer is down here, and you input your numbers up here with switches. And that is how you make a 4-bit adding machine.